A couple of episodes ago, we heard from Dr. Jeffrey Liker about the lean framework for minimizing waste and maximizing efficiency. You may have also heard about Six Sigma. It's a framework for reducing the probability of creating defective products or delivering erroneous services down to less than 0.01%. Hi, I'm Alicia Butler Pierre, and today we'll hear from another PhD with a focus on Six Sigma and how you can apply its principles to your organization. I remember when I first started learning about Six Sigma, I was intrigued by the fact that despite their best efforts, most large enterprises never achieve Six Sigma. And even more interesting is a personal observation I've made over the past 20 plus years. It has to do with the role that geography and a country's culture play in whether your Six Sigma project will actually be successful. And you're about to discover why that is, plus so much more. So grab a pen and paper to take notes. Our next masterclass is in session. This is season 13, episode 161. Let's start the show.
Welcome to Business Infrastructure, the podcast about curing back office blues of fast growing businesses. If you're a business owner or operator looking for practical tips and solutions to scaling your business in a sustainable manner, you're in the right place. Now here's your hostess, Alicia Butler Pierre.
Having a tough time trying to explain ideas over a video conference? Try the Think Smart Whiteboard. It's the fastest whiteboard software in the world and allows you to upload flowcharts and write on them while your colleagues are watching remotely. Call us today for a free demo. The number is 1-866-584-6804. Or visit us online at getmytablet.com. Now that's smart. Think smart. It's season 13 of the podcast, and if you haven't been here in a while, welcome back. If it's your first time listening, our theme this season is operational excellence. We're talking about what exactly it is and how you can achieve it. Joining us today in Corona, California to contribute to this discussion is another special guest, Dr. Frank Barsi. And when it comes to operational excellence, he's an OG. Dr. Barsi worked in various technical lead positions for 40 years with companies like Boeing Aircraft, Lockheed Martin, and Parker Hannifin Aerospace Group. In fact, he helped develop projects like the primary flight controls for the F-35 and the F-22 Raptor, which is known as the best fighter jet in the world. And we are very privileged to be in his company today because he's going to share with us best practices for achieving operational excellence. Dr. Barsi, welcome. How are you today?
I'm feeling very well. It's in Southern California, over 100 degrees, but we are inside the air-conditioned buildings.
Awesome. And I realized when you and I first met that I did not properly call you or address you as Dr. Barsi. I just kept saying, Mr. Barsi this, Mr. Barsi that. And it wasn't until I really looked at the bio that your daughter, Christina, shared with me that I said, oh, I have to correct myself. So
well,
now
that is understandable.
Now, Dr. Barsi, not only are you a U.S. Army veteran, but you're also like a Six Sigma veteran as well. And I'm so glad that your daughter, Christina, connected us. Your background is so fascinating. And I know you're from Hungary originally, and you came to the United States as a teenager, and shortly afterwards, you joined the U.S. Army. What led your family to relocate here to America?
Well, it is a long story, but I'm going to make it very, very short. When I was very young, around 3 or 4 years old, my parents separated in Budapest, Hungary. And my mother emigrated to the United States. And I stayed with my father in Hungary, and that's where I was educated, schooled, and basically raised by my dad. Me and my brother, I have an older brother who's 4 years older than me. He's also a doctor, he's a veterinarian. So what really happened, I left Hungary. You have to understand Hungary was a socialist country behind the Iron Curtain back in the early 70s, you know. and been that way since World War II. So I were not able to come to the United States or get out of Hungary without escaping Hungary. So I escaped Hungary. I basically swam to a lake between Hungary and Austria. And once the Austrian border patrol picked me up, I was able to contact my mother in New York, who lived in New York since my parents separated,
Mm-hmm.
and I was able to instantly emigrate the United States because I was her son and I was underage. So I automatically qualified for legal status in the United States. As that time
Wow.
they call it the green card status,
Mm-hmm.
the legal immigrant status. And of course, once I joined the military, the U.S. Army, I joined. I basically were able to get full citizenship once I become an adult.
Okay.
So this is how my American career started.
Wow. So what a story. Did your father know that you were leaving, or did you just kind of
Actually,
leave under the cover of night?
no, none of my family knew that. I originally
Oh,
belonged
wow.
to a Jewish family, and I was connected to a Jewish organization who helped people escape from socialist countries, ultimately go to
Mm.
America or go to Israel or so on. So what really happened, I escaped unannounced. Nobody knew what happened to me until I was gone and showed up in New York. And I swam 3 miles in October in a very cold water. I choose that way because there's Russian border patrol controlling to the western borders. Actually, it was me and two of my older cousins. Believe it or not, I'm the only one made it across. Both of my cousins were killed, shot at the border by the Russian border patrol.
Oh my gosh.
It was a very dramatic exit for me, But I was not almost 16 years old, so like 15 and a half years old. I was an excellent swimmer because I was a member of the Hungarian border polo team for years. So I could
Wow.
swim. So this is basically the short version of my story to get to the United States.
Oh my gosh. And even though we've talked before, I didn't know this part of the story. Oh my goodness.
I would not put something like this in my bio or my other.
No,
But that's
but I
something
think
else.
you should. I mean, wow. We all talk about, we all talk about freedom and democracy and these ideals that certain countries espouse. But to hear this, I mean, this just adds a completely different perspective, I think, to everything that we're about to talk about also in this interview as well.
Yeah, it's very interesting because I do talk to other immigrants and they all declare, you know what, I arrived to this country with absolutely nothing. I left the communist socialist Hungary or Soviet Union and so on. I always tell them, I left only in a swimming trunk. I really didn't bring nothing. you know.
Just you and your dreams and those swimming trunks.
Exactly. But very interestingly, when I was 10, 12 years old, I already know I will go to America and I will live in America. That
Mm.
was my dream, that was my goal, and I even made master plans on maps how to escape from communist Hungary to make that happen. When I was like 10 and a half years old already.
Wow.
You know,
I mean, I have chills, literally, to
so,
that's such a brave move. Especially with entrepreneurs, we talk about, being entrepreneurs are extreme risk takers and we do the things that other people aren't willing to do and we're bold and we're daring. But my gosh, at 16 years old, to work up the nerve and courage to devise a master plan to escape with literally nothing, venturing and talk about venturing into the unknown and to know that you lost some family members along the way. It's just incredible. So you get to America, you reunite with your mother, and at that, I would assume you're close to you enroll in high school and graduate, or did you shortly thereafter enlist in the army as soon as you turned 18?
I was born in December 15th. So exactly when I turned 18, I right away went to the U.S. Army, took the test. And the very right after New Year's, I believe in 4th of January, I remember like it was today, I basically entered the service in the military. I took basic training in Fort Dix, New Jersey, and all my training then started going from then on. This is how I wind up in Louisiana, where you're familiar with. I,
Mm-hmm.
my advanced infantry training was in Fort Polk, Louisiana. you know, then I went to Fort Benning for jump school, then Fort Bragg for ranger school. Then I did wind up in Vietnam. You know,
Wow.
So I have a long, interesting thing before, but uh, make it very short. I I served 3 years active duty and 3 years reserve forces. So when I left the active duty, I right away start working as a machinist. I grew up in a machine shop. My father was a master machinist and an engineer, tool and die maker. So I was very familiar with that profession. And I started going to school using the GI Bill. So basically, I was a volunteer when I went to the military. So I earned the GI Bill. So I could get housing, with $1 put down, the guaranteed loans. I could get education. So one of the rules was for 10 years after you separated from the service, you can go to school for 10 years long, and the U.S. Government will pay for it. So now I start using that money to go to school. So I started to various schools in Southern California. The very first degree I earned was a Bachelor of Science degree in mechanical engineering. And the
Yes.
very first job I got was not a mechanical engineer, but was a quality engineer. and that's also have a very interesting story. I applied for a mechanical engineering job with an aerospace company in California, and they called me for an interview. After the interview, they informed me they can hire me, but not for the mechanical engineering job position, but the quality engineering position because they don't actually have an opening for mechanical engineering.
Mm.
So so I said, quality engineering. But interesting, I did not even know what quality engineering was.
I was just going to ask you that. Did you even know what that was? What did
No,
that
I never
mean?
even heard of the term. So
Okay.
I start investigating. So I start looking in the dictionary. They were not in a dictionary. None of the encyclopedia didn't even existed in there. Well, remember, I'm 65-year-old today, and this took place over 40 years ago.
Hmm.
In the late 70s when I just got out of the service, and actually is or a very early 80s around that frame. uh, Carter just became the president. So that time
Wow.
from Mr. Ford, I was in a service with Nixon was ousted to the Watergate business, from office.
Mm.
So this is the era. This is the 60s and the 70s hippie era when all this went on. You know, so the interesting thing was I started working it, and very surely I did realize that I did have a very good mechanical engineering background, and I started learning core engineering from other core engineers who worked at the department. Within 1 year, they made me the lead of their group, because of my mechanical background. And of course, my accent was even a lot stronger back then. I even told them one time, how come you guys sending me to making this training course and speeches, and I'm the one who speaks the worst English in the group? They said, no, no, we like that. When you speak, everyone listens.
Hmm. I
because
guess it
they
was
want to
something
understand.
different. Yeah,
They
yeah.
want to understand what you're saying.
That makes sense. They have to
You know,
literally, they
you
have
know.
to listen. They have to pay very close attention to make
Yes.
sure they understand.
Yeah.
So what exactly is a quality engineer then?
Well, the quality engineering, believe it or not, actually was created and forced by the US government for some time and company. The problem was after World War
Mm.
II, all this utopia took over, and manufacturing in the United States was blooming. And one of the area in manufacturing was really doing is aerospace and military business. Those are all the naval ships, the submarines, and of course, all the aircrafts they were making. The F-16 was the number one aircraft back time in the military. I spent years on the F-16 flight control systems. Even so, that was created before I did the revising it and modernizing it and so on. But the point is, the quality engineering was the one who basically planned the product quality before the production of the product and ensure the product is to its specification or its promised contract before it's delivered to the customer. And of course, it was a new profession. The quality assurance organization, what they called that time ASQC, just was created. they were actually giving engineering degree for non-engineers, grandfathering them in. Now, at the time when I became a core engineer, they could not grandfather me in there because I was not that kind. So they basically grandfather me in based on my Bachelor of Science degree in another field, in a mechanical engineering. So first, there was no rule you have to have a 4-year engineering degree. At the time when I became the core engineer overnight, it was already the rule you must have a, a 4-year degree. So what happened, the reason they pushed me over, I found out from engineering side to the core engineering, is they couldn't find any core engineer who has a 4-year mechanical engineering degree.
Mm.
Because people with that degree didn't want to be a core engineer, they want to be a mechanical engineer and designing stuff.
So, is it safe to say, Dr. Barsi, that you were literally one of the part, or I guess part of the first group of quality engineers in the US?
That is correct for the time, yes. Also, I was Dr. Deming from Japan just started coming back to the US and start lecturing for the Americans. Remember, the American industry is rejected his system. That's kind of forced him to take the
Mm.
system to Japan. And of course, the rest is history. Now we do know what happened in Toyota, Mitsubishi after Mr. Deming involvement, and what happened to the American automotive industry after that. You know,
Wow.
so
It took
so
off.
as time went by, I was very young. Remember, I was in my early 20s. So I was not really the greatest experienced engineer. I was new to everything. So I was learning and soaking everything up like a baby,
Hmm.
and learning to walk and run and so on. So as time went by, I got very, very interested in because first time I realized that the outcome of things, the way it is, can be improved and changed to be a lot better outcome. Most of these companies were suffering from, a very high rate of rejection and a very high rate of waste and scrap rate. You know, and the
Hmm.
reason they were able to do that in the aerospace company because they were riding on a U.S. government contract. you know, and the airline contracts, and they were very well fed and very well funded sources. You know, so there was not a problem to make very expensive aerospace parts, and the aerospace was so expensive because they very well paid the aerospace workers, and they have huge amount of waste, which basically was lost money. So to make up that, they just raised the price of everything to accommodate for all that waste. I don't know if you heard remember the $800 toilet seats on the aircrafts and so
Oh
on.
my gosh.
Those were the era. The toilet seat was better into a home, but you bought for $15 than that little tiny toilet seat they put in the airplane for $800. And so this is how it went. Now, when the U.S. government start finding out literally they've been ripped off by the aerospace industry, they start putting specifications in place to control that. And I don't know if you ever how close you got to the quality engineering groups in the past, but the specification was one of them called the MIL-Q 9858A, and the other one was the MIL-I 45208. The MIL-I 45208 came first, and it was basically a spec how a product should be inspected and how the inspection system should be controlled. So all the products shipped and actually verified is meet its adverse type specification. You know, then that was not good enough. So later they decided they need something better. So they come up with another specification called MIL-Q 9858. And this specification was basically created. So now create an inspection program, a quality program. And you're not only inspecting part, but you're actually planning to make good part to begin with. You know, inspection is mean you're just sorting the bad parts. You
Right.
throw out the bad parts, you're shipping the good parts, and you charge the customer for both. Of course, the price will
Hmm.
have to take in the losses. So if you put a program in place to which have prevention in there, then you can. And the mistake they made because they were government entity, they were not the highest qualified people to create this specification, and they were very unusual system to enforce this specification. Basically, the specifications were written and they enforced them to the letter bad or good. And they were still getting bad parts because industry find out how to prove compliance with the specification and still ship non-conforming part. you know,
Mm.
basically to poor quality. And this is all took place because actually the planning of to produce good parts beginning and to verify you have good parts, those plannings were faulty because the system didn't check the verification planning, is only checked have procedures in place which said you inspect the part, or procedure you will wash the part, you will pack the part correctly, or you provide the service to satisfaction, and so on and so on. And so what really happened is all this was met, that the goal line was never crossed. So basically, the industry they could prove compliance and still ship the same type of product with the same waste and loss they shipped before. So this was basically the pioneering and the beginning of quality engineering, which eventually, as we know today, took you to the advanced product quality programs and advanced design quality
Mm.
programs. What we know today, APQPs and so on.
So, Dr. Barsi, if I may just kind of interject
Yes.
really quickly here. So I want to make sure that I understand, and that for those who are listening understand. So you get your first job as a quality engineer. Were you were working at an aerospace company and they were making different parts for airplanes? Is that what you're describing?
That is correct. They
Okay.
basically already making primary flight controls. It was a
Okay.
smaller company. I only worked there a short time, and right away I was picked up by Boeing. And the
Ah,
way that
okay.
happened, because Boeing was one of their customers, and when a Boeing representative was coming, they met me there because I always met with them when we were churning the product over to them, and they turned a liking to me, and they offered me a position in a Boeing
Okay. And
company.
so basically what you've been describing is that prior to having these formalized quality, I guess, quality control groups or departments within an organization, quality basically consisted of the parts are already produced. And once they are produced, when it goes through that inspection period, anything that doesn't meet the specifications or that's considered faulty or defective, those parts were just simply, I'm assuming, handpicked and removed and put in a what we call scrap, as you mentioned earlier, or waste.
Yes.
But quality with these new quality departments, and what your role was as the quality engineer was to say, hey, wait a minute, we don't want you to have to separate the bad parts from the good parts. We want to perfect this production process to where we're only producing high quality parts that meet the specifications every time. Is that the objective?
That is correct. Yes.
Yes. Okay.
The waste was not only spent on throw away the parts and remake them, but also spent a tremendous amount of effort to try to save those products. You know,
Yes. Mm-hmm.
basically the way they wanted to save those products is basically rework, repair, and try to put it back in a usable condition. So of course the government specs were constantly revised to start to have more and more strict controls over these activities, because the government only want to make sure one thing: when I finally get a shipment, is usable. I do not have to return it and stop the aircraft. And so on. But they didn't really care much about the cost yet. And of course, as time goes by, the government's changing. They start changing the cost, and they will start really have a concern over the cost and try to reduce and drive down the cost of purchasing those aircraft. So to continue, then I wind up at Boeing, and Boeing picked me up because they saw an interest in me in this process. And my prime functions at Boeing was Boeing that time went into the big push called standardization. So what they did, they like to
Mm.
standardize every process that the Boeing factory does, and every process the supplier deploys to making Boeing parts. This was in a Boeing aircraft and a Boeing military side, just as well. So they start publishing specifications, which they call them today the BAC specs, or the Boeing military specification, to how to do just about everything. So if you sign up with a Boeing to make a part for an airplane, they actually control how you find the raw material, how you prepare the raw material, how to make the parts, how you assemble the parts, how you test the parts, and how you ship the parts. All of that was into the specification. And many of these early specifications were adapted from them because I was in part of writing this specification. specifications. One of my job was to create the specifications and visit all these manufacturing sites. You know,
Mm-hmm.
so a lot of the specification was taken from the original aircraft company, it's called McAir, which is McDonnell Douglas Aircraft, and that's also merged at one point with the used aircraft. So this was the background of the before Boeing and Lockheed heavy involvement. It was only used aircraft, McDonnell Douglas, Lockheed, General Dynamic, and Boeing. These were the big boys,
Mm.
at that time. Some of these guys disappeared now, you know, and now it's only down to three big guys, Boeing, Lockheed, and Northrop, and so on. No. So the old specifications, we were modifying, revise them, and create new one, but we create a written specification. Now, as soon as this was done, the US government took these specifications and created a military specification from them. They copy the masses and just take the Boeing numbers off of them and put mil spec numbers on them. Then all
Okay.
the mil spec born all of a sudden. So I can tell you half of the mil spec was very critical flight control mistakes authored by me because it was from the original McAir and original Boeing
Wow.
specs I wrote. Back then, or modified or created.
When you say mil spec, how do you spell that?
Mil spec is stand for military specification.
Oh, okay. Okay.
They are a DOD, the Department of Defense published specification. They are DOD military specifications because the Department of Defense was doing all procurements for the US government military, Air Force, Army, Navy, Air Force, and
Mm.
Marines. I could probably write books about this whole history and process, which I made one time.
It's fascinating for me, being that I'm in this space, and obviously not in aerospace, but just being in this production and lean and Six Sigma type of world and process improvement, quality, operational excellence. So this is really fascinating to hear the genesis of how all of this started.
Exactly. And I
Yes,
was
and
right in the middle of it.
yeah, and it wasn't that long ago. I mean, I was born in the 70s, so that, I
Yes, it was not that long ago, I'll tell you
wasn't
the
that
truth.
long ago.
Actually, you were already alive when this thing went on. But so
Yes.
I know we kind of run out of time, and we probably should do one time another podcast, sometime break it down to the elements of these things. That the quality and the process control and the Six Sigma and all of this all come long after all this. And
Yeah.
the very first control of not just manufacturing and production processes, that processes general when they first start to come up with some scientific method, and a statistical process control was the first, and they refer them to the SPC. But the first time when they introduced statistical process control, that was a landmark in the industry of controlling quality, because
Mm.
statistical process control idea wise is not to control quality after the process, but control during the process and monitor the process as you process the product. And if the process shows you it goes in a direction which eventually could become non-conforming, you modify the process to prevent that. Therefore, at the end of the process, you yield 100% all the parts you plan to produce. You know,
Hmm.
and that was really, really take over first by the American automotive industry. And that was Ford, Chrysler, and General Motors. This was the main companies who adapted it. And they actually the one who originally created the first APQP and the PPAP process, which is the prior production approval process. And of course, that's exactly the time right after that when the American electronic industry, Motorola, and they have General Electric and several other companies start to also worry about quality because they were losing very rapidly to the Far East.
So, speaking of that, we also had Dr. Jeffrey Liker. And I know you and I, during a previous conversation that we had, we talked about his infamous book, The Toyota Way.
The Toyota.
Yes, yes, yes. So it's very interesting to hear how we're now, as you're walking us through this timeline, this quality timeline, talking about statistical process control, how now we're shifting into the automotive industry, and even I guess Motorola falls under electronics?
It's probably a little bit before your time, but Motorola made at one time the best cellular phone in the world. you know, and
Yes.
they actually literally the pioneer of the cellular concept. The cellular
Yes.
phone concept. And so they are the one who created the originally Six Sigma plan, you know.
Right.
And the Six Sigma plan was basically because they were such a high production, those small electronic parts. They were basically machines was popping this out left and right. Then other machines which assembled and very small human involvement in them. So they had to perfect the process, and they can predict, what's going to be the outcome, because they cannot run a process for a day and they find that they have 5 million scrap because the machines start putting out scrap immediately, or unusable product. That the
Mhm.
losses was so great they could not have that kind of losses, which could lose a whole year worth of production in 2 days or 3 days. You know,
So as you moved from this, I don't want to say shift, but I guess an evolution beyond statistical process control into this Six Sigma methodology that some engineers over at Motorola come up with, and you were one of the last people to receive training. You mentioned W. Edwards Deming earlier, who
yes. Oh, he was one of my mentors.
unfortunately,
Actually,
yes.
I was one of his disciples.
And what
I
does
was
that
one of
mean?
his. Oh, that means I was one of the peak students who were teaching his methodology.
Okay. Okay.
You know,
And
the,
what
that
was
means
that?
14 points.
Yes.
you know, and
Okay.
it's ancient history, but in Japan, he was a legend. All through the Far East, he was a legend. Matter of fact,
Mm.
every company, how they do the Baldwin Award here, they were doing the Deming Awards in Japan, for companies who put out the greatest quality automobiles or electronics and so on, you know. And he's basically the first one who took the early masters like Schuhart and all the mathematical statistical techniques to implement into a production plan. And he is the one who basically come up with the original aspect. His philosophy was that as long you can control the product by repeating the product, even if the outcome is bad, you can fix it. But if you can control the product, so every time the product or a service is produced, a slightly different method or service produced, you cannot improve nothing because you don't know the process. You don't know the
Mm.
steps in the process, how it was performed or produced. So step one, you want to standardize everything to the much as possible, you know.
Yes.
And,
And reduce the variation.
yes. Well, basically, you want to reduce the variation. His word was always eliminate the variation.
Eliminate.
Eliminate it completely. Reducing variation means you still have variation. As long as you have variation, you're still unpredictable. So variation ultimately is your enemy in everything. Remember, everything what you do in a business environment doesn't matter if you're producing a product or you're producing a service. There's only two kind of business: either service or manufacturing or producing. If when you're producing a service or providing a service or producing a product, whatever variation you have in that, how you produce that service or how you produce that product is basically make that process unpredictable, because you don't know the outcome, because you don't know exactly when something goes wrong, what could possibly went wrong, because you don't know how it was performed.
Yes.
So step one is that the improvement is, first of all, find out the variation in the methodology of how you produce or how you provide. Then once you what you want to do, you want to remove that variation, you document that process, and you freeze that process, and you enforce that that process can only be done this one way. Now, you and I had a conversation before why North America is so different than from the Far East,
Mm-hmm.
implementing some of this advanced tools. Well, in the Far East, especially in Japan and Korea, with an old feudal and samurai culture, they were very easy to implement a process because those guys, they will follow that to the letter. If the process 1.7 and now you open the window and jump out, they would actually do that because they think that's all calculated and has to happen. They will unquestionably follow the process. That is not the case in the culture in North America, because the North Americans are conditioned and trained to question everything and put your own ingenuity in. Accomplish the test the best way you know how or the best way you can. You know. So the problem is over here is, because of that, it was very difficult to control all the processes, because the
Mm-hmm.
processes will erratically purpose many different ways,
Yes.
by different people.
And it's so funny because if you read any, I would say, modern day type Six Sigma book, it will tell you how difficult it is for American companies in particular to achieve what's known as Six Sigma.
That's correct. And the
Yes.
reason is that only companies were able to truly achieve it who took the human factors out and finally automated the entire process. And they achieved that right away.
So people are the X factor.
You know.
Okay.
So, and I can tell you later, maybe, I'm not sure we're going to have time in this podcast for that, but ultimately, Boeing sent me to the Far East, to Japan and Korea, to study the advanced quality system Deming put in place.
Mm-hmm.
That's how I wind up in Mitsubishi and Toyota and so on. I spent 3 months with them, back and forth, to live with them. And I learned so many interesting things, but the number one thing what I learned, that people were culturally very different. I mean, this is the
Yes.
first time when I see the office were laid out for them. There was no room for them to make decisions. They were decisionless. Every decision was made by a planner or management. I mean,
Hmm.
even the desks were laid out where the phone goes, where the pencil goes, where the notepad goes, and where they can put their hand when they're resting it. And they put yellow tapes on a desk and identified this is where the phone, this is where the calendar, this is where that. Then the floor had yellow
Wow.
tapes where the chair goes, where the desk goes, and everywhere was exactly the same way. Now, when they start introducing them in the US, first they bring the, probably you heard the 5S concept.
Yes.
Then those other concepts. Oh, there was basically a uprising and a pushback against it by the people, because the people said, "No, you want to make me a slave. No, you want to make
Mm-hmm.
me a thinkless machine."
Yeah,
Well,
robot.
yeah, but the sad part, and that has some merits and truth in it also. So the solution is different. So I studied all of this, and of course, the company. I changed company. Worked at Boeing about for 5 years. Then I came to another company called Parker Aerospace. They were a flight control manufacturer, the largest flight control manufacturers in the world. They are designing and manufacturing 90% of the free world airplanes, flight controls, military and commercial. So if you look at Boeing from all the way to the 707 to the 777, they design all flight controls and made them. Matter of fact, I was one of the engineers who designed the first fly-by-wire on a 777, which was a new concept at the time. But the
Mm-hmm.
point is, I wind up with them because I heard their reputation, I heard they pay better than Boeing, and I heard they are really a people company, and they were, you know. And so I got involved with them, and this company was very good to me. And when they saw how much education I got, they decided they send me to more schooling and continue my education. 90% of all my education was done during working hours. I even all my homeworks I did at work. you know,
Wow. And
I mean,
and
they just paid me, and that's how I finally wind up with all those credentials.
yes, and so just to name those credentials, you have a master's degree in metallurgy,
Yes,
two PhDs,
yes,
everybody, one in material science and engineering, and the other in theoretical particle
theoretical
physics.
particle physics. Yes,
I
yeah,
have
you
no
see, all
idea
right.
what that is, but it's very impressive, Dr. Barsi.
You ever watch those guys who come on TV and talking about astrophysics? Particle physics is quantum physics. This is breaking down to the less than the atomic levels of the materials. We are not in the neutrons and the protons levels,
So
So,
is that
you know,
like Dr. Neil deGrasse Tyson and
yes, it's
I
nuclear physics. Yes.
okay, and I recently just started watching a lot of Dr. Michio Kaku.
Oh, yes. Actually, I know him in
Yes.
person.
Oh, really?
Yeah.
Oh, we need to talk after this after this episode. I want to meet him. You've
Well, I
had
met him 3 times, to my because of my affiliation with Caltech.
okay, okay. Now you've had, oh my gosh, so many achievements when it comes to, again, quality, operational excellence, process improvement. I'd love if you can tell us specifically one of your favorite success stories. I'm sure there's so many, but if you could just pick one that you can tell us kind of in
Yeah.
detail about. And before Dr. Barsi shares one of his favorite success stories with us, I'd like to set the context in which we'll talk about that success story. It'll be from a business infrastructure perspective. Now, if you're listening to this show for the first time, Business infrastructure is an operations system for linking people, processes, and tools and technologies to ensure that growth happens in a profitable and sustainable way. Dr. Barsi, what's one project that you're most especially proud of? And can we talk about that in the context again of the people, the overall process that was used, and what was the end result and some of the, I guess, some of the technologies that you all used that would still be applicable to businesses today?
Okay, very good. Well, actually, there is one project which is standard almost all projects that I ever worked for, and has to do with titanium as the material. Actually, today I'm probably the fifth most titanium expert in the US, but it happened to be in a in an aircraft program called the V-22 aircraft. I don't know if you ever heard or see. This is that aircraft which is can take off vertical takeoff as a helicopter with dual propellers and turn into an airplane and fly forward at a lot faster rate. It's called the V-22 offspring. You know,
Oh, wow.
well, most of the parts in this air are made from titanium, but the main rotor body and some of the flight control manifolds are made out of titanium castings. So what? And they've been trying to produce this casting for 20 years now. They had a 100% rejection rate on this casting, and they were all due to porosity and imperfection within the casting material. Because the nature of the castings, when you pour it in titanium, is more difficult because of the higher temperatures, the temperatures which require the melting process, is basically trapping air and create all this porosity, which create weakness in the material, and they actually have to either when they machine it, they cut into holes, so they have to throw away the material, or the material is so weak when they done a stress test, when they have to throw the materials away. And each one of these casting costs around $60,000 a piece. you know, and we making hundreds of them. So I calculated out in 20 years of production, they lost $4.5 million throwing away castings.
Oh, my gosh.
So okay, so the casting was produced by one of the largest titanium producer in America called Alcoa Hamet. I don't know if you ever
Oh,
heard the
yes. I know
company,
of
but
Alcoa.
Alcoa Hamet is huge, and they are the one who's basically started and founded the entire aluminum business in the United States.
So, just a quick side note, one of my very good friends, she is an industrial engineer. Her very first job back in Suriname in South America was for Alcoa. So
Ah,
they have a,
so
yes, they have
small
a,
world, yes.
yes, yes.
So they are back in Michigan, actually, at Whitehall, Michigan. Beautiful place. So I flew back there to look at it. And my background that time, I was actually going in school to get a PhD in material science engineering from Caltech. Also, I already had that theoretical part of PhD. So ultimately, I created a Six Sigma project to improve that castings to better one. But what really happened, I invent during this process all through the time, I invented a completely new process method which could create 100% porosity-free titanium casting or aluminum casting or other castings. And that's basically, I revolutionized that entire industry. So Alcoa Hamet went into partner with me, and they did all the experiments and all the design of experiments what was required for that, of course, free of charge, because they want to have a credit for it. They were part of who developed this, and they wanted to own the technology after that.
Okay.
So this technology is not patented by me, is owned by Aqua Hamet.
Okay.
So what was really the way the methodology was, I basically sat down with the engineering group, about 10 the best material and process engineers, and they collect them to all through the Alcoa world. They have like 80 division now, probably 150 division all over the world. They collected the best engineers, and I basically had three different manifolds, three different types, which had to be improved. They all suffered the same thing the last 20 years. So I put them on the table. I said, now we're gonna do something we never done before. We're not gonna do the normal failure mood effect analysis, the design failure mood or the process failure mood effect analysis, the FMEA, like we
Mhm.
always do on this thing. But we're going to do that. But first, we're going to do something new and different. We're going to do a defect map on the parts. because the parts is so big. So what I told them to do, now we're going to pull out 20 years of rejection and we're going to put on a spreadsheet every area which casting was rejected for some reason for porosity. And we did. So actually find out each casting had about 28 area which suffered from this. So I took the part right in front of them, I took a big blue marker and I circled the area where there are porosity on the last 20 years and those 28 area. Then I told them, well, what? Then we started going to the manufacturing process itself, the casting. What can we do to improve so it doesn't have porosity? But it find out, which is the entire industry is suffering from, the forging and the casting industry born right after during World War II and right after World War II. And their purpose was that industries to create a product which you can pour into the mold. And when you pull it out, there's very little machining left to do on it. And
Mm.
so what they call is almost net complete. So the only you have to do about more alteration, do about 10 or 20% machining. Usually where the part is mounted and the inside you have to machine out with precision machines to make a functional part. And everything was net finished to the final size. And when you mass produce, the product was a lot cheaper and more repeatable to produce because they were basically made the mold, and whatever the mold produced, that's the product they keep pouring and pouring for years. And of course, it was a very expensive process, a very slow process. But because of that, they have to alter the contour of all these parts to the level. It was not ideal to pour in a temperature, and it was trapping air because they had sharp corners, score radius, many different technical things which could cause to trap air. So I realized that the world has changed. There's no reason to machine these parts, like only just 10% of them. Now, 30, 40 years later, we have these 5 axis machines which can basically machine aluminum, titanium, or steel in a fraction of the cost to pour a casting. So what I said, okay, let's mark all these areas where the porosity, and I'm gonna add raw material to that area till the porosity goes away and the material is free flow under the temperature. And we keep adding material, and this is design of expensive. We added all the material at once, the mold, we poured. Was not enough. We added another set more. Once it was finished, the part looked almost the same it looked before, but those critical areas had another quarter-inch material to half-inch material added into it. You know, then I told the engineers at Parker, only thing you have to do, not you're machining the part anywhere, change the programs to profile those areas out. Believe it or not, they only had 6 minutes added to the normal machining to profile those areas out, in the machines. You know, so ultimately, I published a white paper, what would be the most ultimate geometrical shape for all material to pour with porosity free. So when we finished, the very first mold was completed to the new process, and the very, very first part come out was 100% porosity filled. We basically radiographic inspected. That's how porosity is fine. So that was step one. Second, two, what I modified, I actually changed the industry standard. I wrote specification how to do digital radiographic inspection. I wrote the first specifications on them. What that means is a 6-hour radiographic inspection could be reduced to 2 minutes. And the digital radiographic, like a CAT program, is identify the porosity, location, and size, exactly where it is, if there is one. So they don't have to weld a lot larger or repair a lot larger areas to get rid of it. So I modified 2 areas. I modified the methodology, how you produce casting in the future, and what's the optimal geometrical shape you must adhere to it, and use conventional new machine method, numerical control machine method to profile those parts out after that. And of course, the method of inspecting those parts, how more accurately and not faster. You know. So basically, all 3 mold was modified. This happened 7, 8 years ago, and they haven't made one part with porosity yet.
Wow. So 100% accuracy every single time.
Now, the sad part is that our core Hamet was helping me on all of this, so they maintain the technology. Before I were able to finish the project on these castings, they were actually negotiating with Parker Hannifin, the company I work for, the prime competitor that's called Moog Aircraft back east in Florida, to do also another prime aircraft titanium castings, and they implemented my improvements in their casting before ours.
Mm,
So actually now all the modern casting they implemented in every casting they have. They don't want to throw away casting, and they don't want to do weeks worth of welding repairs and that kind of thing.
sure,
So
sure.
the greatest achievement was is I basically revolutionized the casting industry, and and I was the first one who's finally convinced Lockheed and Boeing and Northrop to allow the suppliers to do digital radiographic inspection versus traditional film radiographic inspection, which is a lot lower, a lot expensive, and far worse because in a radiographic inspection, a film is kind of like a doctor. An expert has to come over like me and look at it and start looking for fractures and porosity and stuff. And maybe he see it, maybe he don't. The digital radiographic, the machine computer will see the fracture and see the porosity and identify without any human involvement. 100% accurate,
Hmm. Now,
no mistakes.
if we had to relate this to, I guess, layman's terms, so there might be those who are listening thinking, "Whoa, this is way over my head," and truthfully, a lot of it is also over my head. But I want to attempt to, I guess, translate this again into layman's terms. So basically, you created there was this issue with defective parts, and based on your calculation, you were able to ascertain that over a 20-year period, 4.5 million, $4.5 million were
About four and a
lost.
half million dollars were
Okay.
lost in 20 years in the three castings.
Yes, and precastings. And so what you did is you basically led an effort to change that. And as you put it, to revolutionize the casting industry, starting with I know with Six Sigma, there's what we call the DMAIC framework: define, measure, analyze, improve, and control.
Yes, that's
Did
the demand.
okay, so and unfortunately we don't have time to explain what that is in this episode. You'll have to come back, Dr. Barsi. We can have a masterclass just on what exactly is Six Sigma, what is the DMAIC framework for implementing a Six Sigma project, and how can
I
you.
would love to do that.
Yes, and I think it would really be useful to talk about it from a service industry perspective, because oftentimes a common myth out there is that Six Sigma can only be applied to a manufacturing process, and that's not
Oh,
necessary.
absolutely not. I mean, just
Right,
remember
that's
that
not true.
if you're doing something, it doesn't matter what you're doing, it's a process. Now you may not do
Correct.
it the same way every time, but that's mean you're just changing the process every time. But the
Right.
fact everything has an input and output, and you can control it. But so Six Sigma can apply to everything you do. Six Sigma can apply how you prepare a meal. I can tell you, you can prepare a meal where it tastes the same way every time and it's finished, but it always slightly different at the end. That's kind
Mm-hmm.
of what the aerospace industry and the automobile industry have seen. The dinner always tasted slightly different than before, and sometimes not so good. And the reason is that because they're not documenting their processes, they were not controlling, enforcing their processes, and because they were unable to improve the process. But
Mm,
the lesson to be learned to what I have done in this particular project is, and all through the United States or the world, I see large companies and small companies, they're suffering from this. When they finally develop the process, they stay with the process, even if the process is not so successful. But they didn't realize that the known technology and the known process that was good 30, 40 years ago, there are far more advanced tools now, and you need to step out of the box and reevaluate if should I still produce this kind of product in this manner.
yes.
Now brand new companies are coming in, they're right away going to the computer technology, the CM technology, and the design, and they're right away using the 3D modeling and all those different things and the final element analysis. I've done many of those. And an aerospace company like ours were doing that. But when it's come to some of the industry, like casting, forging, It was cleaning the thing. As long as I have a casting, I get the same part every time. Of course, they didn't. They're not even close. They look alike. I don't know if you ever seen a foundry, but anytime a casting taken out a mold, there is a guy come, the lowest paid guy on a totem pole comes and start grinding and sanding that casting to remove all the dirt and
Mm.
all the material still hanging off from the mold and where the material is flowing and all of that. And every single part looks slightly different, like a work of art. you know,
Oh, okay. I
and
understand.
this, and it was close enough when you have plenty material on that. In the aircraft industry, that material had to be removed because weight was a very important thing. So what happened? They start designing in the 70s, 80s, and 90s a type of a casting which could create after the parts with the thinner wall thickness. But now the castings were not really sufficient to hold that kind of tolerance was required to always have a safe part. So what happened? They were always testing the parts with pressure test, or inspecting wall thicknesses, and everything didn't meet, just get thrown out. Everything meat was still fair enough, good enough. Then some of them become overweight at the end when already a $2 million fly control is created, and they have to take it apart and remove that part which caused them to go overweight. Always the casting or the forging. you
So, because of the new casting process or the new casting that you invented, that you created, that you designed, engineered, and created, it reduced that amount of, well, it sounds like it eliminated, not eliminated, but significantly reduced the amount of additional manpower required to do that additional machinery to get the part just right. And here's I think the important lesson for those who are listening right now to take away from this. Because of that, they were able to truly reach mass production. It sped up the process. It reduced
Oh,
the
absolutely.
costs. Yes, it reduced the costs. And when you're able to produce more in the same amount of time, that's what leads to the profitability. That's what leads, and revenue, obviously, but getting to that profit as well, because you can increase your revenue, but if your costs are still going up, you're not necessarily going to achieve profitability. But what Dr. Barsi is describing is actually increasing that capacity to produce more in the same amount of time, meet that customer demand, reduce costs, and ultimately increase profitability. I think
Well,
it's the
ultimately, what happened, because they were a sub supplier to Parker, the company I work for, I were able to renegotiate the price, and the price was dropped more than half. The
mm,
$250,000 price was down to $110,000, per unit, and the lead time went from a 6 months delivery per unit down to 4 weeks.
whoa, six
That's right.
months
You
to
know, so
four
so the
weeks.
improvement for part. So this was really a qualified Six Sigma, one of the greatest Six Sigma project that company ever had. And furthermore, I got my PhD based on that because I this was my PhD
Oh my gosh,
experiments and thesis. It
that is
counted,
amazing. Now,
and I didn't have to fund that. Alcoa Ahmed did all the funding.
well, that's even better.
Yes, because they wanted the technology.
Yes, that's even better. It was a win-win situation.
Yes,
So some of the tools that you did mention, and we'll make sure that we have links to this in the show notes of this episode. You mentioned the FMEA, which stands for failure modes and effects analysis. That
yes.
is one of, by far, one of my favorite Six Sigma tools. You also
That's
mentioned,
actually, I am one of the most expert in the West Coast on that. And if you ever want to
oh,
have just a side talk between you and me on it, I did do some changes on that also, which improved the process. Remember, the original FME was adapted for Ford, Chrysler, and General Motors. You know, in fact, I
mm,
do have the advanced product quality planning. Everything they ever published, I own. That's another thing at Parker. So I become a trainer on that because I were able to, when I said all those parts were improved, it has to do with how I modified. How do you do a more accurate FMEA, on the processes? And that's not only on the manufacturing. We did basically, process failure mode effect analysis and design failure mode effect analysis. I actually were able to help Parkers to reduce the design time for like a 3 years to 2 years to like 1 year by running the failure mood effectiveness is what they do, how they design the products.
Well, I definitely will be following up with you because I'm literally working on one for a client right now. I'm literally completing an FMEA. So
Oh,
if you're
cool.
listening, yes, for those who are listening, you have no idea what that is. Again, make sure you look at the show notes to this episode so that you
Oh,
can
very good.
see, yeah, an
I probably should
example.
watch that, and
Yes.
you probably
Um,
should have a side talk on it. I can give you some clues. And I think we are really, really running out of time.
yes, I know we are. I'm trying to wrap it up here, Dr. Barsi,
You
but
did ask me to give you one thing at the end, and I did miss
yes,
some notice and about the recommendation. I'm going to give it very
yes,
quick. But
please.
I would recommend a website for the International Aerospace Quality Group called IAGQ. I'm a member of that. IAQG. I'm sorry, IAQG.org. Okay, you need to get on this, and everybody, you need to get access to the materials and download it actually and use it. You need to be a
Mm,
member, but you do not have to pay. Now, what's really nice about this, they do have the full APQP, the full Six Sigma, the full, every educational aspect so that you can access from it. And the person who actually the president of I know him personally, the IAQG was the director of quality at Parker for all aerospace group. I worked for a person who worked for him under the earth. You know, I worked for a lady whose name was Jerry Hermé, and she was actually the director of quality and general manager one time at Cessna Aircraft. And also he was acting the GM at Northrop one time.
mm.
So I have connection from a lot of these high level aerospace groups, and she was the director of quality who not hired me, but who basically brought me into the quality group from engineering side at Parker. At Parker, I worked 50% of my time I was there in 35 years in quality, another 50% in design engineering, the designing stuff.
Wow.
You know.
Well,
So I have both background. So I think we're probably going to have to conclude this segment. We
yes,
ran out of time so
unfortunately.
soon.
I
There's
told you
so
it would
much
go
to
by
tell,
fast.
I know.
I know, and there's so much more we can do, and I really do think we need to talk about that master class, putting together some type of master class for those who really want to take a deep dive into this stuff and get walk away with practical tips for
Yes.
applying these principles and these concepts that you've shared with us to their respective businesses. What's the best way for people to get in touch with you, Dr. Barsi? If they I know you are retired now, but you are very obviously very passionate about this work, and I know that you still do some consulting.
Actually, I was doing consulting with a consulting company, which took some of the engineers from Parker. After during the pandemic and different, I dissolved that because I found out it's appeared to be I was the only one doing the work. So I decided to consult on my own. Uh, I, all of the consulting what I have done recently was through an international organization. And I can give you their name.
Yes, please.
Just give me 1 second.
Sure, sure.
And they are kind of nice because I do the consulting. They connect me to the client, and the name of the site called Alpha Site. I don't know if you ever heard of them. They are
Alpha
not
site?
consult Alpha Sites. They are not consultants. The entire organization are developed on the idea. They find a client, and then they try to find a consultant to help the client with the problems or the need they have.
Okay,
So
like a
they basically
matchmaker type
it's
service?
a
Okay.
middleman matchmakers.
Okay.
And originally when we started my consulting business, I don't even know how they got hold of me, but they got hold of me somehow from somewhere, probably lucky.
Okay.
And next thing I know, I started to do this consulting contract, and they were almost exclusively all overseas aerospace companies. Yeah.
Hmm.
So I had to be really, really careful how I consult them because there is laws in the United States not to export technology or certain type of technology. Now the
Mm.
good thing is I'm also trained on what technology you can export and what you cannot. I went through many, many training classes on it. I got certification on it. So I'm good at it to sort out. So I had to be very careful. They always wanted the technology I was not allowed to give. Of course. you know, you know.
Well, I'm so grateful to you for coming onto the show and just letting us get inside of that beautiful brain of yours and
Well,
to
I don't know about
hear.
that.
No, seriously, because as I described you at the very beginning, you're like an OG when it comes to this type of work. And I especially appreciate you talking about, again, kind of taking us along that timeline, that journey for quality and process improvement and operational excellence, starting with you being one of the very first people to become a quality engineer here in the US. And then how it then started to evolve into the standardization of processes. And then from there on to statistical process control, which you helped us understand is being able to control quality during the process and not after you've actually completed the manufacturing process or you've actually have already provided the service and then going back and trying to figure out what went wrong. And then how that
Right.
from there, it led kind of, I guess we kind of have a branch here, it branches off into kind of two parallel flows here, where we have Six Sigma coming out of Motorola and then Lean coming out of Toyota. This has been phenomenal. I must repeat this. Something that you said earlier was if you're providing a product or a service, whatever variation you have makes that process unpredictable, and you simply cannot improve or control an unpredictable process. That's why
That
standardization,
is correct.
yes, is
Every process
so
has to be bring into control, even if the outcome is not what you want. It's got to be in control first.
correct. So, as far as people wanting to again be able to tap into your wisdom, Dr. Barsi, or maybe somehow connect with you, should they go through that consulting site that you mentioned, or is there another better way of
Well,
getting in touch with you?
no, that consulting site is I would not recommend it. Is I don't believe they even American owned.
Oh,
You know,
okay.
it's something I just happened to got connected, and I was very well paid consulting some companies, and I have no problem to consulting any company anywhere in the world toward product improvement, APQPs, advanced quality, and so on. But I do have problem to actually giving American aerospace technology. You
Hmm.
know, you know.
So, should
So
people email
so
you, or I don't want to put you on the spot if you're not comfortable with people reaching
I
out.
am not comfortable with that. I would like to talk with you on a side,
Okay,
maybe
sure. We can do that.
on that.
We
And
can
what we
definitely do
could
that.
do, we could set something up that people could contact me. You
Okay,
know, I have no
sure.
problem. I've been retired for 2 years now, and I am a little bit bored, and this pandemic didn't help me. So basically, I do a lot of other things. I basically do my hobbies now. I'm an advanced photographer. I love landscape photography, and all my traveling in the world, I always took a camera, thousands and thousands of pictures everywhere. So I'm a busy man.
Hmm.
That is all leisure time. I
Yes.
still like to be get connected with this before I forget all these things what went on and basically what I know. I still, even today, I still buy books on quality and systems and engineering and all that because I'm still reading them and still interested in them.
Yeah, still learning. Learning is
Learning is a never endless process. It's
that's
a
right.
continuous
That's right.
process. But that's like product improvement. You can never arrive. You can always improve.
Right.
A lot of people does not understand Six Sigma. When you achieve finally Six Sigma, this does not mean you arrive. What does that mean? You finally have defect-free product. you know,
Right.
with your processes, but you can still improve to reduce the processes to have the time or
Mhm.
a lot cheaper than what you're doing now. You know,
So, you've heard it, everyone. If you want to, kind of pick Dr. Barsi's brain or maybe have him take a look at a project that you're working on, contact us here at the show and we will make that connection happen with
I
Dr.
agree to
Barsi.
that. Actually, I would
Yes.
like that. I am,
Okay.
as I said, I'm almost 66-year-old. I'm 65-year-old, and I'm no longer feel like to be in the management position, and I have to manage.
Yes.
you
No,
know,
I get it. I
and this
understand.
is perfect for me because you'll be the manager.
Oh, thank you.
You know.
Well,
And
it's
since it's
been
a non-profit organization, it doesn't really matter, isn't it? Yeah.
Well, it's been a real pleasure, Dr. Barsi. Thank you so much for spending time with me today, and I'm just soaking up all of this knowledge. Thank you so much.
Thank you for having me, and it was honestly a pleasure to talk.
Thank you. Now, for those of you listening, don't forget to check out businessinfrastructure.tv. That's where you'll be able to access links to all of the information that Dr. Barsi has shared with us. And there's a lot. There's no need to type out that web address because you can just click the link that you see in the description of this episode, wherever you're listening to the podcast. Click that link and it'll take you directly to that list of resources that we're talking about. You'll also find more information about the HubSpot Podcast Network, as well as our sponsors. Make sure you support them because when you do, it helps us keep this show free for you. Again, click that businessinfrastructure.tv link that you see in this episode's description. Thank you so much for tuning in and for being a loyal subscriber. Remember, stay focused, be encouraged, keep operating as good on the inside as you look on the outside. This entrepreneurial journey is a marathon and not a sprint. Until the next time.
Thank you for listening to Business Infrastructure, the podcast about curing back office blues with Alicia Butler-Pierre. If you like what you've heard, do us a favor and subscribe, leave a rating and review, and more importantly, share with your colleagues and team members who could benefit from the information. Join us next week for another episode of Business Infrastructure with Alicia Butler-Pierre.